Hi, I'm Arnold. In today's lesson, which forms part of our series on data handling or statistics, I want to use our developing understanding of probability to make sense of a game. The game that we're going to explore was published some years ago in a magazine of the Mathematical Association. And this game provides us with an excellent illustration of the power of probability in making sense of situations. Probability theory is that branch of mathematics which is concerned with trying to predict the outcome of events in terms of numbers. That is, predicting the likelihood of different outcomes in terms of some numerical value. Before we get started, let's cross to Asunda and find out what questions the students there have for us.
Well guys, as you can see, we're all very excited to be back at Langlaagte. The guys are happy to see us and I'm certainly happy to see them. But there's lots of work to be done, so let's get to it. Hey guys, today we're at Langlaagte Technical High School, and in today's lesson we're going to be looking at probability but analyzing a game to be specific. And to help me out with my first question is Jablila. How are you?
I'm fine, thanks. And you, Asanda?
I'm very good, thank you. So how's everything going?
Okay.
You good?
Yeah.
Okay, so tell me what's up, things that you've been up to, and do you know what I want to know? How do you hang out with your friends and have fun? What do you do?
Go to movies, chats. That's all.
Just chill.
Yeah.
Okay, I like the sound of that. But now let's focus back on the maths, right? You go ahead and you ask a question.
Games and probabilities. Now you're talking my language. Can I use probability to win a game when playing games?
Hey, that's a good idea. Can we, Anna?
It is true that many people who play different games rely on their understanding of the situation. That is, they rely on their understanding of the probabilities involved in the situation to plan their strategies. Before going further, let's link what we're doing to the curriculum. Data handling, more formally statistics, is the branch of mathematics concerned with the collecting, organizing, summarizing, representing, and misrepresenting of data so that we can analyze it and draw conclusions or make predictions. The field also deals with probability, our attempt to express in numbers the likelihood of a particular outcome of an event. In this lesson, I want to use our understanding of probability to make sense of a game that could be played at, say, a fun fair. To start out, I want to introduce you to the game and explain how it is played. The game consists of a series of blocks. To play the game, you place your marker on the starting square and then you toss your coin. If the coin comes up heads, you move forward one block at a time. By contrast, if the coin comes up tails, you move forward 2 blocks at a time. Now, you play the game until you either land on the lose block, in which case you've lost and the game is over, or you land on the win block, in which case you've won and the game is also over. This kind of game is often seen at fun fairs or fairgrounds and other places like that. Typically, you pay the owner of the game a certain amount of money to be allowed to play. If you win, he or she gives you a teddy bear or something like that. And if you lose, well, hopefully had some fun. Of course, whether you win or lose, you're welcome to play again. You probably have to pay for that turn again. Our interest in this game is to determine whether or not it is fair. That is, we want to know whether you will win it as often as you lose. One way of determining whether or not the game is fair is to play it a large number of times. That is, to determine through experimentation whether or not it is fair. What we're doing is determining the experimental likelihood of winning and losing the game. Let's get started. Our marker's on the starting square. We spin our coin and we get a head. We move forward 1, and I'm afraid our first game results in a loss. Let's start again. On the starting block, we spin our coin. Once again, we get a head, move forward 1 block, and I'm afraid our second game also results in a loss. Let's toss our coin again. A head. By now we know the results of that. Another loss. We start again. Finally a tail. We move forward 2 spaces and we're in that block over there. Spin our coin and we get a head. We move forward 1 block and follow the arrow to the top. Let's spin our coin again. We get a head. That means we move forward 1 block and we follow the arrow, and finally we win a game. Let's play 1 or 2 more. Start, spin. Maybe we shouldn't. Head, we lose again. Starting once more, we spin our coin. We get a tail, 2 blocks. A head, 1, and follow the arrow to the top. Spin our coin again. We get a tail, 1, 2, and I'm afraid we have to follow the arrow to lose. At this stage we've played 1, 2, 3, 4, 5, 6 games, and we've only won 1. And with that, it's time for you to play the game a number of times yourself. Let's cross to Asanda and find out what happened when the students played the game a number of times.
Thanks, Anat. And our next question is from Nelson. Nelson, how are you?
I'm fine, and you?
I'm very good, thank you. So what's been happening?
Nothing so far.
Nothing.
But Asanda, I've got a present for you.
Oh, thank you, Nelson. You're so sweet. You see, now I'm going to blush. Okay, you go ahead and you ask your question.
Well, it looks like we're losing the game more than we're winning it. Is it possible that the game is not fair?
What? Is it possible?
An excellent question. As you know, my own experiments revealed the same thing. I seem to have lost more often than I've won. Is it possible that this game favors losing?